our power rule? Our power rule is that the power of the argument on a log can become its what? The power rule. Somebody save me. It can become its what? The power of the argument can become what of the log? Huh? It's coefficient. That was the word we were looking for. Thank you, Jacob. You redeemed yourself a little bit right there. Good job. Coefficient. It can become our coefficient. So notice here, when I have this log written as log base 2 x squared, and I'm like, huh, what transformation rule is that? Well, don't worry. It is a transformation rule. It's just not written in a form where you can read it as a transformation. Does that make sense? So we're going to rewrite it using the power property. Make sense? So when we rewrite this using our power property, this 2 is now going to become our coefficient. So what we're looking at is g of x equals 2 log base 2 of x. Okay? So when there's a power on the exponent, it's actually a vertical dilation. Okay? It's a vertical dilation because it's outside away from the x. And you know, why lie? There's no reason. So y is just going to be what it is. If it says 2, that's being multiplied by 2, it's being multiplied by 2. So this is now a vertical dilation by a factor of 2. Okay, that's what that would look like. All right, so to prove that it's going to look like that, we're going to graph the parent function and then graph the dilation. So it says graph both here. Pull up Sylvie. Hey, girl, hey. I'm going to go ahead and already have the parent function graphed as my y2, so I'm going to just change this. I'm going to insert, so second insert, and I just need to change this to 2. And I'm going to delete the 4. So when I graph, there was my transformation. And then here is my parent function. Notice that it was stretched vertically by a factor of 2. You see that? Is it okay if I don't actually draw it? Because, you know, I want to leave on a high of me drawing really good in the last one. And I don't want to mess that up by trying to emulate it now. Huh? I don't want to mess that up. I feel pretty confident in what I've already done. So, you know, uh, I'll cheat. How about that? Oh no, what are you doing, Sylvie? Huh? I graphed the log base 2 of x, our parent function, and then I graphed our function written in power form. Well, so 2 log base 2 of x. No, I graphed log base 2 of x, and I graphed 2 log base 2 of x. Okay, cool. Let me be great. All right, so now here we go. Now we're going to describe the change in the output values over equal length input values of the intervals. This is that AP wording that's so fun to try to interpret, right? And so essentially, it wants us just to say, as your x increases, how did it change from f of x to g of x? So we're going to write this one together just to make sure we're getting used to the format of what I hope this is what they want as an answer, okay? So as x increases by 1 unit, the y values in this case, I'm just going to say our vertical dilation. Now, Ms. Robertson, if you think that they would want something more than that, please let me know because I don't know. Yeah, dilation by 2 or vertical dilation. I think we have to specify that it's a vertical dilation. The y values are vertically dilated. Y values are vertically dilated by a factor of 2. Is that right?
Vertical, right?
We're not allowed to say stretch and compress anymore. I know it's crazy, right? So I'm trying to make sure I'm. Does that make grammatical sense? Still a factor of 1. Mm-hmm. Okay. I think I wrote that right. As x increased by 1 unit, y values are vertically dilated by a factor of 2. That makes grammatical sense, right?
What is that in like layman's terms for like people, like us normal people out here? What happens really to the x? So the x increases by 1.
As the x's are increasing, the y values are being multiplied by 2. But we can't write that. We have to use certain words. But yeah. But yeah, I think that's good. That's good, right? That makes us seem real smart right there. I believe this. What do you mean? Which part? The log?
I even type that. Log.
You have the 2, and then you'll hit alpha window to change your base. Alpha window 5. Hudson reminded us a little bit.